Hello everyone. So today we'll see a next experiment in the course Theory of Motion 2. Of course, it is to draw a half empirical sheets on topic cam and follower. So let's start. Aim of the practical is to draw cam profile. So already in theory sessions we discussed about how to draw cam profile. But along with drawing cam profile, our aim is not to draw only cam profile for different motions, but at the same time and study variation in pressure angle with respect to change in base circle diameter and to draw P circle for both cases. So if you see this statement carefully, in this experiment we are not going to draw only cam profiles for a given statement. At the same time we have to check what is variation in pressure angle with respect to change in base circle diameter. So if for a same statement, let's say in this case base circle radius is given is 30 mm. So for this 30 mm radius I will draw a cam profile. After drawing cam profile I have to change this base circle radius and I have to check what is effect of this change in base circle radius or diameter on variation of pressure angle. Means I have to study first what is pressure angle also, and then effect of change in base circle radius on pressure angle. Also we need to draw a P circle for both the cases. Both the cases means case 1 when radius let's say 30 mm and second case when radius is get changed. So before starting this experiment we need to see what is first pressure angle and P circle. So let's see that with the help of sheet I drawn. So to study the concept of pressure angle and P circle radius, we need to understand basic procedure first. As it is discussed in theory classes, how to draw cam profile, which is I am showing here with this dark color, that we are not going to discuss in detail now. So for a given problem statement, let's say what is given data, the follower is an I-page follower, its stroke is 30 mm and the motions are, for rise it is uniform acceleration and retardation for 120 degree angle, then followed by dwell, and the return stroke is with SHM. So it is with SHM. Minimum radius of cam, that is base circle radius, is given 30 mm. RPM of that cam is 800 RPM. So this is given data, and for this, from this information I can draw this cam profile. How to draw? We know step number 1. We need to draw a displacement diagram or S theta curve we can say for a given motion. So I will draw displacement diagram. You can see here this one is uniform acceleration and retardation, then dwell, and followed by a SHM curve. So as already discussed with you how to draw displacement diagram for different motions and then how to draw cam profile, we will not discuss in detail. Just the first step is only to draw displacement diagram, and in second step we have to draw cam profile. So you can see this cam profile as it is radial follower. So we drawn this first minimum radius of cam, it is 30 mm radius. So this one is base circle of 30 mm. Then we need to transfer that rise, dwell, return on cam profile also. So here as this cam rotates clockwise, we assume, the cam rotating anti-clockwise, hence we need to move this follower around this cam in clockwise fashion. Hence we start dividing this cam in clockwise way. So this one is theta O, this one is theta D, and followed by theta R. So we can divide this circle in theta O, theta D, theta R as we know. Then we get different divisions from displacement diagram as rise stroke is divided into 6 parts. Here also we take 6 parts. So 1, 2, 3, 4, 5, 6 representing rise. This 6 to 6 it is dwell, and then 6 to 12 is nothing but a return stroke. So we get these points 1, 2, 3, 4, 5, 6, 6, 7, 8, 9, 11, 12 on a base circle. After that we need to transfer this displacement, that is 1A, 2B, 3C up to 12 on this cam profile also, and for this we need to join these divisions with cam center as it is radial follower. For offset, it is a different procedure that is known to us. So I join 1 with center, 2 with center, 3 with center, likewise up to 12 with center. And these lines joining cam center with this division 0, 1, 2, 3, 4 represents follower axis, or you can say represents direction of follower motion. After getting direction of follower motions, we need to transfer displacement of follower from S theta curve to this follower axis. Let's say 1A from S theta curve, I will get here 1A, B, C, D, E, F and so on. So likewise, when you get these points, that is follower displacement, in last step, I will join these points by smooth curve to get a cam profile. So this is your cam profile. This procedure is already known to us. Means how to draw displacement diagram, how to draw cam profile for different follower motions, for different either radial follower or offset follower, that is known to you. So that I am not going to highlight. So now we will discuss about our practical aim. Here, so I completed this cam profile for a base circle radius of 30 mm. But as per our statement, we need to check variation in pressure angle for change in base circle radius. So I have to draw this cam profile again for different base circle radius. So I will draw a cam profile for same given data. This given data remains same, means stroke remains same, all angles remain same. Only change is I have to change base circle radius. So for that base circle radius, I am drawing, you can see this. I already drawn a cam profile for a radius of 45 mm. So initially I drawn a cam profile for 30 mm. In the second case, I drawn it for a 45 mm. Now for these two base circle radius, that is for 30 mm and 45 mm, for a same data, how pressure angle get changed, that we need to study. So to get variation in pressure angle, we will see first what is pressure angle. We know two basic curves in cam profile. One is a cam curve and other one is a pitch curve. In this case, as it is Nyquist follower, this curve represents, that is cam profile, or you can say cam curve, is also called as a pitch curve, as trace point is tip of the follower. Basically, what is pitch curve? Pitch curve is a curve drawn by trace point. Assuming that this cam is stationary and the follower is moved around the cam in opposite direction of cam rotation. So if I move this follower around the cam, and the curve traced by that pitch trace point is nothing but a pitch curve. As trace point is this Nyquist, this point of the Nyquist follower, hence this pitch curve and cam curve is same in this case. But remember, for follower like rotor follower, this pitch curve and cam curve will be different. Okay, so this one is pitch curve. Once we get pitch curve after cam curve, once we get pitch curve, then what is pressure angle? As we know, pressure angle is angle which represent stiffness of the cam profile. In general, in detail we will see it is nothing but angle between normal to pitch curve. So as this is pitch curve, if I draw a normal to pitch curve, so angle between normal to pitch curve and direction of follower axis or direction of follower motion is nothing but a pressure angle. I repeat, pressure angle is that angle, or it is angle between direction of follower motion. So you can see here, this represents line joining cam center with these divisions. Let's say 1, 2, 3, 4, 12. So if I consider this first point, let's say line joining cam center and the point on base circle, if I join them, this line represents follower axis, or you can say direction of follower motion. Likewise, we have for different positions, we have this follower motion. Likewise, means line passing through 1, 2, 3, 4, 6. If I join with center, they are representing follower motions. Direction of follower motion. Angle between direction of follower motion and normal to pitch curve. So at every point, let's say A, B, C, D. Why at A, B, C, D? Because we have to draw normal to pitch curve. So this A, B, C, D up to L are the points on pitch curve. So at these points, if I draw normal to pitch curve, let's say here, I have to draw normal to pitch curve at point A. So for this, to draw normal to pitch curve, I have to draw first tangent. You can see already tangents are drawn to this curve. So let's say at this point A, this represents tangent. At point B, This one is tangent. Already tangents are drawn. I'm just showing you. So at C. Likewise, to draw normal to pitch curve, I have to draw first tangent and then draw normal perpendicular to tangent. It represents your normal to pitch curve. So at that point, whenever we need to find out pressure angle, draw tangent to pitch curve and draw perpendicular to tangent, which represents normal. So this line now represents normal to pitch curve at point A. So angle between these two lines, that is normal to pitch curve, and direction of forward motion represents pressure angle. Likewise, I can find out pressure angle at different points. The points we taken are, let's say, these 12 divisions corresponding to 12 divisions, A, B, C, D up to L. So at each point I can find out pressure angle. You can see here now the pressure angle is already found out at different points. So let's say at point A it is 12 degree, at point B it is 21 degree, at point C it is 25 degree, and so on. So you can see how the pressure angle is varying for each point. So it is 12, 21, 25, 26 degree, 1 degree here. So you can also understand what is actually relation between stiffness of the curve and pressure angle. So high pressure angle means what, low pressure angle means what, that also you will observe for this. So I completed drawing different pressure angles for a one cam profile, for a given cam profile, for a 30 mm radius cam profile. So I drawn variation in pressure angle for this cam profile radius. But we need to check how this pressure angle varies for different base circle radius. Okay, so for this we need to repeat this procedure for a radius of another base circle. Let's say it is 45 mm here. Okay, so we can draw it later on. Before that, I'll try to explain one more term which is required, that is nothing but a pitch circle. So after drawing these pressure angles, we get different pressure angles. The point on a pitch curve having maximum pressure angle is called as a pitch point. So you observe carefully, the maximum pressure angle is, it is 12, 21, yes it is. So it is here, it is 32 degree. So this point, that is I point, is having maximum pressure angle, and that angle is 32 degree. So there are some points on a pitch curve where the pressure angle is maximum. So point on a pitch curve where the pressure angle is maximum is called as a pitch point. Okay, and if I drawn a circle with radius is equal to cam center to that point, that circle represents pitch circle. So if I join this, let's say this is the radius of the pitch circle. Join cam center and that point and draw a circle. That circle represents pitch circle. So we have to draw a pitch circle also. Already drawn it is. So this circle represents pitch circle. So we completed our procedure for a one base circle radius. Means we drawn S theta curve, then we drawn cam profile. After that cam profile we get pitch curve. In this case it is similar. Once you get pitch curve, then you find out pressure angle at different points, and the maximum pressure angle point is nothing but a pitch point. If you draw a circle through that pitch point, it represents pitch circle. Okay, because they told you as per aim, we need to draw pitch circle for both cases. So I completed for first case. Now I have to repeat this procedure for any other base circle radius. So here it is 30 mm. Now you can see we drawn this cam profile. We drawn this cam profile for a 45 mm base circle radius. Now again procedure is same. Means we have to draw a base circle radius which is not same as previous base circle radius, which was 30 mm here. I will take any other. It is not necessary 45. You can take 35 or any change in radius. So I drawn it here. Once you get base circle radius, then as per procedure discussed, we need to draw this cam profile by transferring distance from displacement diagram. Same displacement diagram I use, which I used for previous case. So after getting cam profile here also, then we need to find out again pressure angles. So how to find pressure angle already we discussed. Just line joining, forward motion and normal to pitch curve at that point represents pressure angle. So angle between that two lines is pressure angle. Here also I find out pressure angle, you can check here 11 degree, 16 degree, 21 degree, 11 and so on. So we check variation in pressure angle for this case also. After this we find out where the pressure angle is maximum. So you can see in this case the pressure angle is maximum again at point I only. In the previous case also it was maximum at I point. Here also it is maximum at I point and it is 27 degree. So once you get the point of maximum pressure angle called as a, if you remember, it is called as a pitch point. We have to draw a circle passing through this pitch point with center as a cam center, and that circle is a pitch circle. So we completed drawing pitch circles for both the cases. You can see the pitch circle for case number 1, pitch circle for case number 2. So as per our aim, what was our aim? To draw cam profile. Yes, we studied how to draw cam profile already. We drawn cam profile. Study variation in pressure angle with respect to change in base circle diameter. So we studied that variation in pressure angle for change in base circle diameter. This is base circle radius 1, here it is, and this is base circle radius 2. So we drawn cam profile for both cases. We see how the pressure angle varies from these two, and to draw pitch circle for both the cases. We drawn pitch circle for both the cases. Yes. So this one is pitch circle for case 1 and this is pitch circle for case 2. But now it is only completion of drawing. We need to analyze something. We are not doing this experiment just for understanding drawing nature. We need to see what happens if we change the base circle radius. So we need to conclude something. As our aim is to study variation in pressure angle, how pressure angle varies if you change the base circle radius. So if you observe, I need to conclude something. What is effect of change in base circle radius on pressure angle? So you can check when the base circle radius is 30 mm and when base circle radius is 45 mm. We drawn one table here. So RB is 30 mm and RB is 45 mm. For these two cases, we have to see how pressure angle varies first, and then we check only maximum pressure angle. So maximum pressure angle in this first case is 32 degree. You can check here it is 32 degree. And for second case, already we seen it is 27 degree. So the pressure angle is 27 degree, maximum pressure angle is 27 degree. Here it is 32 degree. So based on this, we can understand something. What happens if I change the base circle? In this case, we increase the base circle from 30 to 45 mm. So if base circle radius get increase, what happened to pressure angle? You can check 32 to 27. So pressure angle get decrease. At the same time, we have to draw pitch circle radius. And it is obvious, if you increase the base circle radius, the pitch circle radius in the first case was 10.14, but here in the second case it is 12 mm, 12 centimeter. So if you increase the base circle radius, pitch circle radius also get increase. That's this kind of conclusion we have to draw. And this conclusion we drawn by using a graphical method. So we completed to draw how to draw cam profile, how to check variation in pressure angle for two base circle radius, and finally to draw a pitch circle for each case. This is our procedure for experiment. I will explain how to draw this on a sheet. Now you can see this complete sheet how we drawn. So in the left corner of the sheet, we need to write statement of the numerical. Even though if you not written statement here, you can write on separate sheets, but you have to write given data as mentioned here. I suggest you don't write statement here, only write on given data. After that, we need to draw displacement diagram as discussed in theory sessions. Then two cam profiles for two base circle radius. Initial case, we drawn it for a 30 mm radius, and for second case, we drawn for a 45 mm radius. Then draw variation in pressure angle, show pressure angles clearly, find out maximum pressure angle, and then draw a pitch circle, determine pitch circle radius. Same here also, see variation in pressure angle, then find out maximum pressure angle, we get pitch point, and then draw a pitch circle. Then here also we can draw a table showing comparison how or what happens when base circle radius get changed, or what is the effect of change in base circle radius on pressure angle and pitch circle radius. Along with this, as a statement, as a part of the statement, we need to also find out displacement, velocity and acceleration curves if asked in the numerical. So you can see this in the right side corner of the sheet. We drawn this displacement, velocity, acceleration and its values. Okay, so this is your complete sheet and these are the answers for the velocity, acceleration and e-pass jerk. So this is your complete sheet. You refer this for drawing and you are requested to upload this kind of sheets on a Google Classroom. I will show you one more numerical and then we'll stop. You see here, this is again second statement, second numerical statement, and of course here we drawn, this is first base circle radius, and for this base circle radius actually the follower is roller follower. Why I discuss this? Because the cam curve and pitch curve is different only for roller follower. For other cases, as we discussed in the first numerical, the cam curve and pitch curve both are same. So here, after getting this cam profile, you can see this one is cam profile we obtain. Okay, so that is your cam profile. After getting cam profile, as per procedure, we have to draw a pitch curve. Remember, pitch curve is that curve passing through a trace point. So in this case, this point is trace point and a curve passing through that point represents pitch curve. So I am just highlighting pitch curve here. Remember, cam curve is shown here, but pitch curve is this one, passing through center of the rollers. So I shown this pitch curve with this red ink. Why I shown it purposefully? Because for roller follower only, this cam curve and this pitch curve are different. And after that, we know how to draw pressure angle. Just line joining, follower motion and normal to pitch curve. So once you get this pitch curve, then draw tangent and draw perpendicular. Then we will get angle like this. So these are the different pressure angles at different points. At one point, we get maximum pressure angle. So you can see in this case, pressure angle is maximum at 17 degree. So here this pressure angle is maximum at this point only, and from this point if we join this, this represents pitch circle radius. So draw a circle. So this circle is your a pitch circle. So this one is pressure pitch point, and this circle represents pitch circle. Pitch circle, this one is pitch point, and already curve is shown, this one is pitch curve, and of course this curve is a cam curve. I just shown for roller follower as it is different, otherwise for all cases it remains same. Okay, so we've seen how to draw cam profile, then how to find out variation in pressure angle for two base circle radiuses. This is for one base circle, this is for another base circle. For roller also we drawn, and then after getting variation in pressure angle, find out pitch point, find out pressure angle, draw a pitch circle. That's what we seen today. Okay, thank you.